Hello everybody, I am Mohamed Reda Sidumu, and today I'm going to introduce to you the Java programming language. Before that, I'd like to thank Minerva Statistical Consulting for sponsoring this video. In this video, we're not going to go deep into the Java programming language, the object-oriented part of the Java language. We are just going to know how to code to write simple programs. We are going to write some funny stuff though. And later, after in the second part, we can have a look at object-oriented programming deeply. But for now, this is just an introduction to the next part. So what are we going to study in this video? How to write a first program. Before that, we are going to see the motivations behind Java, why it's good to learn that language. How to write a first program, what we will need for that. How to declare data types, primitive data types, string types, variables, arrays, operations, expressions, conditional statements, and reading from the console, as well as loops. So why are we going to study Java? Well, according to TOB Index, it's the most used programming language in the world. We can have a look here. Java tops the list of TOB Index by a rating of more than 16%, before C and C++. It has become the language of choice for implementing internet-based applications, for network or for devices that need to communicate over network. Also, according to eFinancialCareers.com, Java is the hottest language to know in banking, for people who would like to have a career in banking. It's also used as well in Android-based apps, so it's basically Java with some packages, some different packages. It's a live and active language. We can see that we have a new version each 1, 2, 3 years. The latest version is Java SE 8, which was released in 2014. What's special about it? It's an object-oriented programming language. It mimics the entities of the world. We are not going to look deeply at what's object-oriented programming in this video, but we would like just to mention that Java is such a language. Java is closely related to C++. They share a lot of similarities as in their syntax. C++ is a direct descendant of C. So if you have any familiarity with C and C++, you will get quickly familiarized with the Java keywords. It's a write once, run everywhere language. A Java program is compiled into a bytecode. Then an interpreter, what we call a JVM, Java Virtual Machine, will execute that bytecode in a targeted machine. Here is an example. This black rectangle is what we call a Java program. A compiler compiles that into a bytecode, an intermediate code. Then we will have in each machine its own JVM. The JVM will take the bytecode and take care of executing it in the targeted machines. So you just need to run your code just once and it will run mainly everywhere. So what we will need for a first example, the JDK, of course. You can just download it from this link. It's free to download and to use. Current version is 1.8. Simple to install. We are going to also use one of the IDEs. There are many. Here we are going to use Eclipse for our examples. It's a powerful IDE, also free to use. You can basically use any type of IDEs if you want. Well, an IDE is an integrated development environment. It will help you to write your code, correct it. It can give you code completion, execute it quickly. So it will help you a lot in terms of time. So here is the first program. The first line here is public class hello world. You don't need to understand what that line means. The next line, we are going to understand it later, but you can understand it fully once we get to object-oriented programming. This line is what we call the main method, the main function. The first line that is going to be executed in any Java program is the one following the first brace of the main method. This is the main. This is its brace, opening brace. So when we run our program, the first line that is going to be executed is this, system.out.println. Let's run it. Here I have Eclipse. I would like to close it first and reopen it. I have downloaded it, both the JDK and then Eclipse. You just need to extract it and you will have these files and directories. So here we have Eclipse, the Eclipse window. Here it's when you open a source file, you will have the source code. And here is the list of your projects. This window is the console where we can write entries or read things. Let's create a new project, a new Java project. We are going to call it example1. Here is our project. We are going to create a new class. As I said before, we don't need to understand what's a class here, just look at it as a source file. We are going to call it test. Well, it says that this name already exists, so it's better to call it hello. There is already a file called test. We're going to remove that one. So we can see that the name of the Java file and the class matches. The name of the class here is hello, and the name of the Java file is also hello, hello.java. This is the name of the source file. So we are going to create our main function, main method, which is the entry point of any Java program. You really don't need to understand for now what this public static void main means. You just need to understand that this main function is the entry point of any program. So the first line that's going to be executed is the one following its opening brace. That line. And we print a string. String is always between the double quotes. And we can see that always we have a semicolon to end a statement. We show what to print. And we save. Then we execute our project. Each project should have only one main method. Here is the output on the console. Hello world. If you want to modify it, put your name here, for example, and you will have. It's not execute. It's not saving. Let's save it and execute. Yeah, we have what matches the string here. So this is a first example. For now, like I said, you don't need to understand these two lines fully. You just need to understand that what's between these two braces is what's going to be executed. We will have time to understand them later. Let's go back to our slides. So this is the IDE, the one we saw just now. Here is a list of all of your projects, console output, the source code, if you open any Java file, and here you will have your class and your methods, and you don't need to worry about this stuff right now. So we just did these steps to run our first example. So let's go to the next slide. So what's the Java platform? We are going to get familiarized with some words or the used language in the Java platform. It's an object-oriented programming. It's statically typed, unlike JavaScript. We are going to see what's statically typed. It has a Java run environment, which is the Java virtual machines plus the Java APA class. The JDK contains all of that, plus the compiler. And we have the compiler that takes any file, .java, this file, hello.java, and convert it into a bytecode, a .class file. Then the virtual machine will execute what's compiled, which is, in our case, hello.class. It's not visible here, but it's the file that was executed to print our hello world message. The Java development kit includes all of these stuffs. The main parts are Java C and Java. The Java C is the compiler that converts your source code into a bytecode, and the Java is the interpreter, the one that executes your bytecode, the .class file, and executed it into the targeted machine. We have other stuffs. You don't need to worry about much about this other applications. Applet viewer is to see applets, for example. JVP if you want to see the Java bytecode. JDB if you want to execute step by step your code. Java doc, how to generate the documentation, create C. You don't really need to go into these parts. Only these two are needed. But of course, Eclipse will hide JVC and Java for you. It will compile and execute without the need to use them. We also have what we call a class path. A class path, when you install Java, it's an environment variable. It includes all where the needed libraries are set. It's a set of directories, and it includes all of the jar files and the classes that are going to be, and resources that are going to be used in your project. Generally, the local file where your source code or your class file is included into the class path. But you can include, for example, if you have any library, a shared one, for example, a library that, for example, load images from the disk, you can put it in your class path, and all of your Java projects will get access to it. A class. Of course, we are not going to look deeply at what a class is. A class is what we call the main unit of any Java program. Any Java program should at least have one class. We just created in the last example one class test, and it contains only one method, the main method. Also, we are not going to see what's exactly a method. Now we are going to look at maybe the building blocks of any program, any Java program or any other program in any other language. It's about data. Data are some zone in memory. When we declare a variable in any language, we book a room in memory for that variable. Just reservation, basically, in the memory to see if we have enough space to put that variable or not. So here, how we declare a variable in Java. We specify the type, int. We are going to see what int means. The name, you can put any name here. We are going to look at to see how there are some rules about naming. And you can also initialize a value. Int is an integer, and we initialized it with the number 7. So number is a memory zone that includes the number 7, that we put the number 7 in this memory zone. Java is statically typed, which means that the type should be known in advance, unlike JavaScript. So a variable, a memory zone, should have a type to know what sort of information are going to be stored into that memory zone. Here, number contains exclusively integers. So, what primitive data types are in Java? We have positive integers, or negative one also, 1, 2, 3, 4, etc. Alphabetical characters, A, B, C. Booleans, true or false. And any type has a name, size, and defo value. Let's have a look. Integer types. The byte is the smallest one. It's just a signed 8-bit integer. It can contain only numbers from -128 to 127. It's not used that much. A short is slightly bigger. Here are the ranges of a short integer. An int is one of the most used integers. It's much bigger, like how you see. Generally, it's enough for most simple tasks. A long is even bigger than int. It's a 64-bit long integer. So if you need very large numbers, you can use long. Here how to declare them. Int I equals 7. We just created a memory zone, an integer named I, and initialize it with 7 number. A byte A, initializing it with 3, and a long B, initialize it with 3. Of course, we could, because we have just 3 here, we could have used a byte, but you should bear in mind that the B might increase. So you are going to estimate your worst case, the largest number that's going to be used in B, and give its type accordingly. Floating point type, which are reals in mathematical language. We've got 2 reals, 2 type of reals in Java. The float, here is the range of a float. Here is a power to 45 and here to 38. It's a big number. Or a double. A double also a 64 bits real, and it's generally enough for most type of applications, except in finance, where sometimes you need something slightly bigger. For simple applications, a float is enough. Here is how to declare them. Float. We put this F to mean that this is a float, because if you don't put an F, it will be considered as a double, this number. And we will have a problem when assigning this a double to a float. So here it's to say this is a float. Here is a double. We can sum them without any problem, and they are compatible between them, and putting them in sum. If you need more, if the double is not enough for you, sometimes in finance you can use the type big decimal. We've got also another type called big integer. Big decimal is a 10 bytes real. We've got other types, for example, a character, which is a single byte for defining characters. A boolean is for defining a boolean type, which is basically just can take only two values, true or false. The string data type. The string data type represents a string of text, many characters. Here is how we declare a string s equals, and put a double quote. If you can see the previous slide, a simple character, a car, use a single quote, and a string uses a double quote, and here you can put anything, really anything. It's a Unicode, and you can specify any string in any language. Here are two strings, s and name declared. We have declared another string called greetings, and with the plus we can concatenate two strings. Hello, this is a space, just to show that this is a space, blank space. And when we concatenate that, we will have here in greetings hello, comma, Bob. In this greetings. How to declare variables? We specify the type, the name or the identifier, and an optional initialization. You're not obliged to initialize it, like in here. Int, the type, it's an integer. Name or identifier, the size, and we initialize it with 10. Here we didn't initialize it. It's optional. Now let's have a look at the rules of naming identifiers. The identifier is the second part. This type, size is the identifier. A is the identifier. Of course, it cannot be a keyword, a Java keyword. We cannot name a variable int. Int is already used for the type integers. It begins only with a letter or an underscore. A, B, C, D, etc. or the underscore. And the rest, so the first letter is a letter or an underscore. The rest can be a mixture of letters, digits, and underscores. Like here. First name, the first letter is F, which is acceptable. Then we can put anything after it. Size is acceptable. Here we started it with an underscore and followed it by digits, which is also okay. So let's have a small exercise here. Which of these are valid identifiers? They are all valid except this one, because it started with a digit. They started here with a letter, underscore, letter, but this one is not valid. The scope of a variable. Where is a variable alive? A variable is alive or accessible between the braces that define where this variable is defined. For example, here we have a brace and we close it in here. So the variable b is alive between these two braces from here to here. But the variable a is defined between these two braces, so it's not alive here in this part after this closing brace. So if we print b here, it will be printed. If we print a here, we will have an error. A is not defined in this part of the program, because after the end of this block, a is destroyed. But b is still alive here. It will be printed. Now let's have a look at arrays. Arrays are collections of data, many data. So like integer or string are just one data, if we can say that. Arrays are a collection of data. So here we declare days as an array of strings with when put it this two things here, string days, it means that our days, this variable, is a collection of data. We can initialize it with many strings, Monday, Tuesday, etc. So it's an array of 7, a 7-dimensional array. We can also create arrays of integers, like this one, sizes, and we initialize it with 5, 10, 3, 55, 3. So it's an array with 5 integers, a 5-dimensional array we call it. If we print it, if we want to access one of the variables of the array, we have to specify the index. The index always starts with 0 to the size of the array minus 1. So here the first elements is sizes of 0, which is the first position. Here we specify the position. This is sizes of 1, 2, 3, 4. We can't go beyond that because our array only defines 5 variables. If you don't want to initialize your array, you can use this int my array equals new int of 8. Here it means we have 8 elements in our array and 8 integers, but they are not initialized. Without any initialization, you can put any values later. We are going to use arrays in examples. The operators. Java defines a lot of operators like C and C++. They share, most of them shares common meanings as C and C++. So we have arithmetic operations, plus, minus, multiply, division, mod, the incrementation operator, plus plus, and the decrementation operator, double minus. Here when we put a double plus next to a variable, we just increment it by 1, and the double minus decrements it by 1. We have logical, that takes boolean, as here it takes numbers, and here logical, it takes boolean operations. We have binary. We are not going to look very much at this for now. We have comparison operations. Is to compare. We are going to use this a lot in conditional statements. I prefer to not give you full details about the following ones. It's better to use them in examples. Here is an example how to use arithmetic operations. We declare the variable double, and this so let's suppose that these are variables A, B, C, D, and we can put any operations between these variables. The priority is like in C. So the multiplication is has a higher priority than plus. So this one is going to be executed before the plus. If you get confused with the priorities of multiplication, which one is going to be executed first, just use parentheses. So parentheses is the most takes the highest priority, sorry, if I may say. So well, here when we put parentheses here, it means that this one is going to be executed first, this one too, then the bigger parentheses. Logical operations, if it's about Boolean operations, for example, if you've got two variables, both are true, and you put an AND between them, the result will be always true. If true and false, the result will be always false. It's like in all logical operations. Expressions. An expression is a sequence of operations, many operations, literal values that are evaluated to some value. Like this is an expression. 10 plus 20 plus 30 divided by 3, and we put parentheses. Here is an expression for calculating the circle of an area. This is defined P 3.14, I think, multiplied by R. We suppose that this R is a defined variable that contains a value. So how to compute the circle of the area of a circle? Sorry. Here is another expression to compute the perimeter of a circle. Math.pi is always defined. We multiply it by R, which we consider that it's a variable that we have declared previously. These are examples of expressions.